So for our second task, we're going to write some software to calculate the first 1 million prime numbers. So if you go into the source code directory and open the primes.txt file and just select all and copy. That'll save us having to type it in later. And then if we just start up Eclipse and select our normal workspace, we should get back to where we were before. If Hello World is still open as a project, just close that project because we're going to start a new one. So File, New, Java Project, and we're going to call this project Primes. Click Finish. And as before, Primes, New, Class, and we'll call this Primes2. Be careful to have a capital P. Okay, finish. And as we've already got the code, we'll highlight the template code that Eclipse has put in and simply paste our code over it so that it removes the template code. And you should find you then have a working Primes project. So we'll just save it and run. And we find it calculates the first 100 prime numbers, so the 100th prime is 541 in 0 milliseconds. So it takes less than 1,000th of a second to calculate the first 100 prime numbers. Computers are pretty fast. They run about 3 billion instructions a second. This code, though, is fairly inefficient. If we put the number of primes to calculate up to 1,000 and run it again, we'll see to calculate the 1,000th prime, that's now 7,919, and it took 191 milliseconds, so nearly 0.2 of a second to calculate the first 1,000. And if I put that up to 10,000, it would take a long time, and it would take far too long to calculate 1 million, which is what we want it to do eventually. It would probably take over a day. Okay, so what we're going to do now is we're going to debug this program. So we're going to actually see how it runs. So if you go to the far right hand side of, let's put a breakpoint next to this line next slot. So go to the far right hand side, right click, and you'll find you can do toggle breakpoint. Now what a breakpoint is a point in our program where we want it to stop when it's running, and then we can step through and see what it's doing. So we put a breakpoint in. Instead of pressing the run symbol, we press this bug symbol, which means debug the program. So we'll click on debug, and it asks us if we want to change perspective, which we do. So we say yes, and our program is now running, but it has stopped where we told it to. What I'm going to do, I'm going to rearrange this window a little bit because I can't see much of the code and I want to see more of it. So I'm going to drag my debug part to here. I'm going to drag the variables to here. Actually, I'm going to close the outline. I'm going to close the breakpoints because I don't need them. I'm going to close console because I don't need it, and I'm going to close the tasks. So I've now got debug and variables. With variables, I want to make sure, if I click here on the view menu, that the layout is in view variables and also in vertical. Okay. Now, when we go into the debug window, there's various things we can do. We can step into instructions, we step over them, we can return, and I'll leave you to experiment with those at some other stage. But what we're going to use is the shortcut keys. So I'm actually going to use F5 or F6, it doesn't matter which one, but I'll use F5 most of the time to step through the code. But I'm going to be keeping an eye on the variables as I do that. Now, all these things that we're defining here are variables. So next slot is a variable, and you'll see at the moment it doesn't exist because we haven't created it yet, but when I press F5 and move on to the next line of code, you'll see next slot has suddenly come into existence and it has been set at a value of 0. When I step over this next line, next num has suddenly come into existence and it has been set at a value of 2. Now I'm not going to talk you through this line by line because that would be particularly dull. What I'll leave you to do is just repeatedly press F5 and watch what happens. I'm doing it rather quickly, you might want to do it a bit slower. What I'd also like you to do is if you expand this primes, click on primes, it will show you the value of the primes table. The primes array. An array is a whole host of values that we're storing that's filled with zeros originally, and as we step through our program and calculate the prime numbers, it is filling the array up. So it's just calculated 5, and I'm stepping rather rapidly and it's got as far as 7. Now this program is pretty inefficient at the moment, so I'm going to make one minor modification to it. So I'm going to stop debugging it for a minute, press the stop. I'm going to make one minor modification. I'm going to put a break in here. I'll leave you to work out what that command does. If you step through it before putting the break in and then put the break in and step through it afterwards, you'll probably work out how it makes it more efficient. So I'm going to save that. My breakpoint's still up here, and I'm going to re-debug it here. So it's running again, and it stops at our breakpoint. I'm going to show the variables again, and you see my primes array is full of zeros at the moment. It hasn't calculated anything. And I'm going to now keep pressing F5. And as you see, as I press 5, the array is gradually filling up. But it's actually filling up faster than it was before, because the code is not having to do as much work as it had to do before. So when you're bored of that, you can stop debugging, and you can close the debug perspective and go back to your coding window. We've got a modified version of the code here. You'll notice since I put this break in, it was taking 0.2, nearly 200 milliseconds before. If I now run this code with the modification, what was taking 200 milliseconds is now only taking 20 milliseconds. So we've made this code quite a lot faster. It's still incredibly inefficient though, and if you go back to the source code directory and open up the primes.png, in there is a version of the code which is much faster, and you might want to make those modifications to the code and try it then, try and work out how that works, and you'll find it is then fast enough to calculate the first 1 million prime numbers in a very reasonable time. I think it'll take about 10 seconds to do that. So that's our second task. Primes, do take the time to take a look through the really fast version and see if you can work out how all the versions are working. You may need to consult some online Java references to really figure it all out. Good luck. Okay, and we'll move on to our next task.